All right, on day 2 of this stuff today, here's what we got going on. The first little part, first section, is just using your calculator. So those buttons that are along the sides on your calculator is the one that is third from the left on the bottom and fourth from the left on the bottom. When it'll say things like this, where it'll say, find log 8. On your calculator, you find the log button, then you type in 8, and then you hit enter. You're going to get a decimal. And that decimal is going to go on forever. Now, depending on whatever they tell you to round to, typically speaking, it's 3 decimal places. So what is the log of 8? Point what? 903. And you're done. Okay? Then on the other context, they'll say the ln of 0.3. Again, that button is near the log button, where you just hit ln 0.3 and hit enter. And what number pops up? Negative 1.204. If I go to 3 decimal places? Done. Are you guys comfortable with the first part of your assignment?
Yeah.
Okay, you just got to plug it in and see what you get. It shouldn't matter for that because you're not doing too much else. So when it says ln like that or log like that, you shouldn't have to because there's not a whole bunch of extra stuff. But it's good practice too, just in case. But as far as the calculator goes, everybody okay with that? Awesome.
Yep.
Now, the next part that we're going to talk about is inverses. Like we did the last chapter, and we're going to deal with some inverses with these. And there's some properties. Just so that you guys know, if you have a function, a log function, the inverse of that log function is actually this, b to the x. Okay? So if I have something like this where it says log base blah, 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 x, and I want the inverse of that, then I write that base to the x, and that's my inverse. Okay, so it's very simple like that, where it would say something like, if g of x was equal to log, Abby, give me a number. 4x, and I said find the inverse of that, then all I have to do is, well, it wouldn't be g. What was the base number that Abby just told me? 4 to the x, and I got my inverse done. Okay, so notice the similarities. The bases are the same. That's the key. Okay? Now with that, we've got a couple other things that will show up. They're more properties that'll help you evaluate or go through some of these a lot faster than normal. If you have something like this that says base, and then this is the same like that, notice how it looks like a log with an exponential also involved. These two bases, are, if they are the same, they cancel each other out, and you're left with whatever x is. So for instance, if I had something like log base 4, 4 to the 8th power, are the bases the same? Mm-hmm. Yeah. So what number does it equal? 8. And you're done. Okay? Pretty quick. Same thing goes if it's written like this. If you have base with a log in the exponent, as long as the bases are the same, they cancel each other out, leaving you what letter? X. So for that one, if you had something like 6, log 6, pick a number. Huh? 24. I heard that first. Are the bases the same? Yep. So then therefore, 24 would be my answer. Done. Okay, so that, do not overcomplicate that. That's something pretty simple to do. If you notice that the bases are the same, they cancel it out, and then whatever's left there is your final answer. Okay? Now, here's where it's going to get you in trouble a little bit. If you see something like this where it says 10 log 4. The other day I mentioned with logs, what number is understood to be the base if it's not written? 10. And we understand this to be base 10 if there's nothing written there. If you want to, you could type 10 to the log 4 on your calculator, and it should come up with the number 4. Now, how did it do that was, if there's no number written as the base for the log, it's understood to be a 10. So as long as these are the same, then it's going to be equal to whatever that number is. So my number is 4. Done. Okay, pretty simple? Good. Now, the one that'll get you is where it'll say 525 to the x. That's the problem that will get you in trouble a little bit. Okay, now, one thing I hope you notice so far up to this point, all the ones can be rewritten as something like a base to something. 25 is 5 to the what? Second, right? So I can rewrite that to say log base 5, 5 squared x. Where did I get the x from? It was already there. Now are the bases the same? Yeah, so what should it equal? 2x, and you're done. Okay, the majority of your assignment is going to be putting in your calculator first and then doing these. What do you think so far? Not too bad? Okay. Now, the next thing, it will say now find the inverse. So if I give you f of x equals 6 to the x, I need you to come up with the inverse. I just gave you the formula, or the way that that works out. If it's in exponential form, we rewrite it as log form. So what would be the inverse of this? Log base 6 x, and you're done. Okay, well again, what did the f to the negative 1 represent? Inverse. Perfect. Okay. What do you guys think so far? Not too shabby? Y equals the ln of x plus 3. Now remember the rules for that stuff before? When it comes to this, when we did inverses last chapter, what were my steps? What did we do? Switched, right? So x equals the ln of y plus 3. Now, how do I solve for y? Now, we need to talk a little bit about undoing things. When we undo adding, we subtract and vice versa. If we undo multiply, we divide. If we undo square, we square root. How do we undo ln? No. Look at your calculators. Your calculators give it away. What's the opposite of lning? E-ing. Right. Okay. Above the ln is the e. So when you want to get rid of ln, you e it. Okay? And when you e it, you e this side and you e that side. So the opposite of ln is e. These cancel each other out, leaving you y plus 3 on the right-hand side. And on the left-hand side, you have e to the x. Now, how do I solve for y? Minus 3 to both sides. And I get e to the x minus 3 equals y, or the inverse. Okay? So whenever you want to get rid of ln, the natural log is what that refers to, you use the natural base number e. Okay? Just like the reason why we did the log was we rewrote it using exponential because the bases. Right? The bases are the same. What do you think of those? Okay? All right, the last thing that you're going to be asked to do is you're going to be asked to graph. Here's the downfall. Your calculators only understand base 10. Okay? So if your calculators only understand base 10, can you necessarily put this in your calculator? No. Unless you know how to. Okay? So when you look at this stuff, here's what you're going to be graphing today. You're going to be graphing log base b x. You're going to be graphing logs. There's two different types. Okay? The first one is when your base is greater than 1. The type of graph will look like this. put it in blue. Oh, that's horrible. I can't do that. There we go. Do you remember the other day when we did exponential growth and decay functions, when we graphed those, where it came either up or it came down, depending on if it was growth or decay? Notice how this one starts up and then goes along. Where does it ride alongside like it looks like it never crosses? The y-axis this time and not the x-axis. So what happened is it got reflected over the line y equals x. That's what happened. It's the same as exponential growth, except for it got flipped. Okay, that's what it looks like. Do you remember on all the exponentials how it went through 0, 1? Or it went through this order pair right there? What order pair do you think this is? Not 0, 1. 1, 0. Okay, so all the log ones are going to go through the order pair of 1, 0, unless we shift it, which we'll do tomorrow, or Friday probably. Okay. Now, on the alternative is, what if your number is in between 0 and 1? What types of numbers are between 0 and 1? Fractions. Right? So if your base is a fraction, more specifically, what type of fraction? Less than 1. So 5 halves would be the one that's on the left. Okay? This particular guy comes down here and rides out that way. Again, what order pair does it go through? 1, 0. Now, here's what they're going to ask you to do for this particular thing. What they ask you to do is they ask you to find the inverse. And that's the step that they ask you to do. Then they ask you to plug in a table of values. Okay? And then they ask you to graph it. Okay, that's what they're officially saying for you to do. So on something like this where it says f of x equals log 3x. Okay, first of all, I want to know what the inverse is. When it's in log form, what's the inverse? It'd be 3 to the x, right? Okay. So if I were to put in numbers, Savannah, pick a number. No. Lower. Whatever. But not 5, because 3 to the 5th, I don't want to graph that. 2. What is, if I put 2 in for x, what's 3 squared? 9. Edie, give me another number. 3. What's 3 to the 3rd power? 27. Tamara, give me another number less than 0. Less than 0.
Like a negative one? Oh, negative 1.
Negative 1. If I put negative 1 in there, 3 to the negative 1 power, what do I do with a negative 1 power to get rid of it? We talked about it yesterday. Flip it over. What's 3 flipped? 1/3. Okay? So I'm starting to generate a list on that particular part. When I plug all those in, what do I get? If I were to plug those things in there, 1, 2, and then up 9, let's just say it goes to there, would be here. And over 3 up 27 would be here. And back 1 and up 1/3 would be real low. I'd be right in this vicinity. That looks like the ones that we did the other day. That's the inverse. Now, if I flip them over, here's what happens when you flip it over. What that does is that it reverses the numbers. So when I flip it over, instead of being at negative 1 and then 1/3, flip it over. What would it be? 1/3 and negative 1. So I'd be down here. When it says 2 and 9, I'd really be at the point 9, 2, which means I go over here 9 and up 2, and I'm this way. 3 and 27 flipped would be 27 and 3, so over 27 and up 3. So now I end up getting my curve that looks something like this. Okay? So when you want to graph logs, because right now you can't use your calculator because I haven't showed you how to yet. What you do is you find the inverse, which is the exponential one, and then you switch the order pairs. That's how you do it. Okay, so you just pick a couple order pairs, as many as you want, probably more than 3 or more, and then all you do is you just flip them over. So when it says 2, 9, on the log one it's 9, 2. When it says 327 on the log one it's 27, 3. Okay, all you do is switch them. What do you think? That's the last part of your assignment today. Okay? So on something like that, or on your assignments, when you look on page 314 to 315, on 27 to 32, it says evaluate the log using a calculator, round your answer to 3 decimal places. That's plug it in and see what you get. Then on 35 to 40, it says simplify the expression. Use that stuff where if the bases are the same, then it's equal to that number. Then on 43 to 52, it says find the inverse of the function. It doesn't say graph, it just says find the inverse. So we're going to switch it over and whatnot. Then on 55 to 59, that's where you're graphing those. So on that, we're 27 to 31 odd, 35 to 49 odd, and 55 to 59 odd.